Hi, everyone. This is our last talk today from a speaker other than our closing word, which you should definitely stick around for. The person that's crowding me on the stage here is Kresimir Antolic. He claims that he's from planet Earth, but he left his lab coat and his goggles at home today. So I'm sure it will be a treat to see his speech. Let's welcome him.
Hi, everybody. As Steve said, my name is Kresimir, and I'm here to talk about building React. I've been working with JavaScript for, well, too long, and I have seen some terrible things there. And React is something that helped me, well, deal with it personally. Now I sleep better at nights. Currently, I'm employed at Oradian as a front-end dictator, and I'm doing JavaScript there. Who is actually doing JavaScript in production here? Oh, God. Who is actually thinking about moving to React on their next project, or actually rewriting their current project in React? Oh, God. OK, so that's actually pretty good. React is a really good technology that brings you great value to your product, and you should really think about it. Everybody who didn't raise their hand, start thinking about it. OK, so what will you get from this talk? Hopefully, you will walk away from this talk with some knowledge about how React actually works in the background, which will probably, maybe, or never help you write better applications. We'll see. OK, so what will we actually do? I will introduce basic React building blocks. We will implement them. We will combine them, and we will get our React. So there's live coding. No, there's not live coding. There's show and tell of code, because there's a lot of code to go through. But there will be a repository, Git repo, whatever, which you can take a look after. OK, so what we won't do here is care about performance, portability, IE, et cetera, React does that for you, but we're doing this for educational purposes. So bear with me, make my life easier. I'm going to do simple stuff here. Simple. So we also won't do lifecycle methods, and we won't use this in production. If you're going to do this, something like this, please don't use it in production. You're going to regret it. OK, so Kreso, what is this React you speak of? Well, usually it's this hunk of JavaScript and XML in one file. That is usually what people think about when they say React. So you have some React component here, state, and some XML that you return that iterates over state for some reason. Well, it's really ugly, but you get used to it after some time, and it actually makes sense. Probably. OK, so what is it? It's a view abstraction over HTML. And yeah, I see that in your faces. What does that actually mean? So it's just a view layer. It's a library that just does the view part. So it's on you to do data manipulation, and it takes care of whatever HTML things it does in the background. So you don't need to know what DOM is, so what HTML DOM is, how to manipulate it. React does it for you. OK, so why would you use it? As I said, it abstracts dealing with the DOM, with HTML DOM. You concentrate on your business logic, your data layer. It forces you to work in a component way, so you actually make smaller components that you can reuse across the application. And it's really well defined. And it has a great community. Community means updates and plugins that you can use on your project, which is pretty nice. OK, now I have your attention. Yeah, thank you. So how does this React work? OK, this is the picture I found makes most sense, and I'm going to use this prop to further demonstrate. So React is this unicorn. It takes stuff in, so your code base, your data, and something happens, and it spits out stuff, which is your HTML code or whatever, and you don't know why it happened, how it happened, you really don't want to know, but it works, and it works perfectly. Okay, now, but seriously, well, usually it's simple. We have our application code, our application data, which changes the DOM, and DOM reacts to events and says to our application, hey, something happened. Okay, great. Let's try to do that in React. Okay, let's do basic React elements. So, live coding, God help me. Okay, so first of all, you know that XML part that we saw before. So we have this. So these things are the same. As far as we're concerned, this hello first and the second one are the same. Why? Because this is JS6. This XML thingy is called JS6, and it's transpiled into actual HTML function calls, JavaScript function calls. This create element, we just creates this. So it creates the type, the attributes, well, props, let's be real, and all the children. So just remember, these two things are the same. And we're going to use this part here, because I don't want to use JS6. Okay. Let's look at the classical React example. This is the hello world example. We see nothing yet, because I'm just showing you how it usually looks. So we have a hello function, which returns the element, and we have a render function, so how to actually spit something out. Okay, let's do something with it. So for this to actually work, we have to implement the render and create element function. Let's take a look again at the hello. It creates an element of type span with class name big and pretty and children webcam. Yeah, okay. And for that, we actually need to create the create element function, which does simple things with DOM, document create element, and render also does something simple. It just pastes the actual item to the DOM. And if we now take a quick look to the console, oh God. Now we have div root, we see it here, and a span element. But there's no classes, there is no children inside of it, so we want to see hello webcam. Okay, now we need to upgrade this to support children and properties. Okay. What we actually do here is pretty simple and dumb. Don't do this because there's smarter ways to do this, but for our example, it's okay. We go through all the properties, so class name big and pretty and everything else that will come after that, and through all the children and just put them inside. That's it. And it's pretty stupid, but now we have hello webcam. Well, that's actually kind of how React works. This is a simple view model representation. Okay, but let's take a look at something more complicated. For example, we have a list of stuff, which is pretty usual in web development. We want to show a list of stuff. So we usually write something like this. So we have a container element which has multiple inside elements. Okay, nothing special. And this is the same. So we have create element, which creates a div, which has no properties, well, props, and it has children inside of it, 3 children. Okay, now we expect to see 2 pictures and a H1. No, we don't, because this says HTML object, because we did something wrong. Because we're using inner HTML. Inner HTML is only for text in our case, so we have to make it support DOM objects. So text and DOM are separate, and you have to take care of it. And this isn't the first time and the last time we're gonna do this. Yeah. Okay. So now we just said, okay, if the child is type of string, concatenate it. If not, then just add it to the element. And here, take a look. We have a root element, which has a div, heading, and 2 images, just as we described here. So now we have a basic structure of elements that we can do. But you know, the first example that I showed you had a component class. So it's a class component that you can use and create multiple components. So it's just something to make our life easier. So it's nothing, it's just a simple class that has a constructor that sets props so you can get it on the instance, and render, which you have to implement. And we also immediately change our list of stuff to extend the component and just rewrote the render function, and it does the same. Okay? The only thing that we had to change was the create element function to know when it's a component. Then we have to instantiate it. Nothing special. It's just programming. And if you see again, this was changed. It works the same way. Great. So why did we add a component? We added a component because we can reuse code most simply that way. Okay, let's add a more complex component now. This is nothing special. We added an image counter component, which is the same component, but it takes in a counter from the props, and it shows it. Here, corn click 0. So it's just passing off data, nothing special, but we see it works. We're going to use this later for an example. And since we have components, we would like the components to be self-contained and have their own state. For that, we just introduce a function called setState in the component that you have to use if you want to update the state. And that's it. For our future uses, we're going to use that for re-rendering of the component itself. So we'll come to that. OK. So now we have a problem. This doesn't have any events because we just showed stuff. And how we would like to, well, I would like to click on something and get a reaction because that was the part of our model that I showed you before. For that, I did a really, really, really bad thing, which you probably shouldn't do. So I added a property on something, on click in this case, did a function for it. It says clicked on a corn and set states for something. And I just said if this begins on, it's an event, so add an event. So it's nothing, again, it's nothing special, but this actually works. We can see it. So go to the console and click corn, 1, 1, 1, 1, 3, 4, 5. If I click on this corn, it's 0, 1, 2. This is 6 again. OK, nothing is being re-rendered now, but you see we have a component which are separate, but the same, but have their own states. OK, and how would I get this to render? OK, let's go back to my talk. So, I mean, from what I showed you now, we kind of implemented React, right? We have all the building blocks elements, etc. But there's one big problem. But Kreso, how do you get state updates? Don't you have to re-render the whole application, the whole HTML there? Yes, yes, you do. So if I would like the counter to say 0, 1, 2, 3, whatever, I have to re-render everything, which isn't a problem for this small case. But if you're working on a bigger application, then it gets complicated. You don't want, if something changes on one part of the page, for the whole application to be re-rendered. For that reason, we have to introduce some kind of optimization. OK, anybody knows how? No, not jQuery. But actually, that's a good idea. Yeah, I know. Let's implement custom logic for every component that they write, with jQuery, for example. Good point. Which we manually say, if this state is this, if it changed, let's update this part of the component for every component. And then we get super performance, because we're updating only what needs to be updated for every component, forever and ever. No. no. We're not going to do that because that's like tedious. You should actually be writing your code, not writing optimization for your code. React does it for you in this case. And we're going to make it smart. How? We're going to introduce a layer between them, which the application directly interacts with. And this layer interacts with the DOM. So as far as the application is concerned, nothing changes. But this part here is the one that's responsible for making any changes. For that reason, we have to introduce something called virtual DOM. Virtual DOM is an in-memory structure of the DOM. So it's your application, but it's in memory. And after something changes, you're being smart, and you see, OK, something changes. I have my current state. I have my next state. Only this part of the application changed. OK, I'm just going to update this part. So as far as you're concerned, you're writing your application, but this layer here is being smart and is updating the DOM only where it needs to be updated. OK? So what will we actually do here? Every time a state changes, we will render the whole application, but in memory. So memory is fast. We will calculate what changed between the previous state and the new state, and we'll only update what's changed. So just to make it simple, this is our data model. This is like our current state of the tree. This is the new thing, and we saw that this changed here. And this part here will tell DOM, hey, please update. And nothing of this will be touched, which is pretty powerful because you can actually write your application. OK, so live coding again. I'm going to introduce vDOM. I won't have... OK, this is going to be a speed run because I don't have time. You can check this out later on the Git repo. So for this, as I said, I will introduce vDOM. So our create element is now create v element, so create virtual element. We have a create virtual element function, it's just a definition that we use later on. So it's just data. And for that, we had to update our render function to know how to deal with it. So create element now takes a virtual element, and the create element now has to deal with the virtual element. So the virtual create element now takes care of how to construct and render something from the virtual element. OK, and if we take a look, nothing changed. So this is still the same. This works. We just introduced a layer, and nothing happened. OK, but now we can touch that layer and do stuff to it. I heard you. OK. As I said, this is just an in-memory representation. But we also would like to have a way to update just this part here. For that, we need a reference. I'm just going to keep this really simple. The reference is the reference to the DOM element you will create. And so our create element function now creates create v instance, virtual instance, which consists of the element, the virtual element, and the child instances, who are, again, elements of v, elements of children of children of children of children. And again, this works the same. So now we have an in-memory representation that also has DOM elements, which we can easily access to change stuff that changed. OK. We can go here. Now we enter reconciliation. Currently, we just were rendering stuff whatever happened. So something came in, we just rendered it. OK, great. But we have to be smart. We said we want to be smart. We only want to change things that actually changed. Now we have a way to access those nodes that changed. Now we have to make something smart that actually says, OK, I have this tree, I have this tree. I have to traverse the tree and find whatever changed and update my HTML DOM. And for that, we have a be-smart function, which just does that. you can see that later in the Git. But I'm going to show you the last commit actually here. If I click now on my Betticorn, stuff is changing. We're not re-rendering anything. We're just re-rendering Betticorn subtree. See? The image counter is the only one being re-rendered. Image counter, corn click, this one is only being re-rendered, and they're completely separate. For this, I had to iterate all children, reconcile, be smart on the children, had to do a lot of stuff here. But these are the reconciliation rules that you have to follow. You can write more rules for this. These are just my rules that are basic ones from React. And that's it for that. Okay, so for your homework, when you get home today, I would recommend that you do lifecycle methods. Should open and update. It's really good to implement this. Implement key props because current code doesn't work with deleting nodes. And implement better reconciliation. So be smarter than I am. That's really easy. And here are some resources. This was heavily influenced by Inferno, Preact, and Dan Abramo. And there's also my repo, which you can find on GitHub, Cybern, React, Korn. And that's it. Thank you.
I'll take the first question. I'm not that familiar with React. Does React do a similar tree comparison of a virtual, like a virtual DOM versus the real DOM? Is that how it reconciles differences?
No, it reconciles the previous state and the current state. Okay. So on a change, it renders the whole application again, but in memory, and it saves the previous instance. It has the same previous instance and the new instance, and then it traverses and finds whatever changed.
The virtual one, is that client side?
Everything is client side.
Okay, and then...
It's in memory, that's the difference.
Right.
You have your code, you have the DOM. The DOM is actually what you see on the screen. Your code is what you wrote, and this part is magic that just takes care of actually what happens on the screen. That's it.
And that is faster than... than the object knowing where to.
That's much faster than going through the DOM nodes because re-rendering the whole DOM is a bad idea. DOM is fast, but repainting and recalculating what happens there is really slow.
Any other questions from someone not me?
I have T-shirts.
I get one, right?
Give me T-shirts. Come on. Question, anyone, anything.
You get a T-shirt if you ask a question, it looks like.
And the T-shirts are nice, pretty. Look at this. No, nothing, really.
One in the back. It's so far away, so far. It's the last day. I'm not running now.
Run.
We have time, right? Should have told jokes in the meantime.
Hey, thank you for the talk. Just a quick question. Are you experienced with Vue.js?
Yeah.
I'm a Vue developer. Why would you recommend me to switch from Vue to React?
I wouldn't.
Thank you.
Time for one more quick question right here. And we have one in the front, too.
Hi, great talk. I'm a back-end developer, and...
I'm sorry.
Yeah, I know. Thank you. So I'm just wondering, if I were to get into front-end, right, would you recommend me React? Right now, tomorrow I want to get into front-end.
It really depends what you want to do. If you're doing something simple, and want to start with some basic HTML and do some pretty stuff without any bigger logic, yes, of course. But if you want to really build single-page applications, there's a big ecosystem around that, and there's a big learning curve around that. So, but yes, I would recommend. But maybe I would also look at Vue.js. That's my favorite framework. but I'm getting money paid for React currently. So.
What's the name of that other framework? Feud?
Vue.js.
Oh, Vue.js. Okay.
So it's a view layer as you.
Great. One final question.
Hi, great talk. Okay, so a thing I saw recently, I think on Hacker News or something, was a framework that used HTML comments for DOM reconciliations. So it would put like little hashes of, next to all the rendered items, and it would actually target those hashes right in the DOM and select the previous item instead of having a VDOM and then doing a diff.
Yes,
Did you try using that sort of thing? Would you recommend doing that sort of things? What are your views on that sort of thing?
Okay, I'm gonna repeat what he said. So there was an article on Hacker News, sorry, which there was a reconciliation algorithm that actually uses DOM directly, not VDOM previous instances. So, and what do I think about that? Okay, so you remember this. I don't care. The thing is, DOM is really fast. If you don't change it, so if you change something on the DOM, it's slow. So if you move out an element from it, and then the DOM actually has to do the recalculations, repaints, etc., that's slow. But if somebody's using directly DOM as the previous instance, why not? I'm okay with it. If it works for you, why not?
That's it. Thanks again, Kresimir.
This is for a woman, so give it to your wife.